We will now discuss another data mining problem known as regression analysis. So, in this week, the 8th week, we will discuss regression analysis along with few other techniques that are essential for data mining. So, we had previously studied mainly two important data mining class beside the association rule mining. One is the classification, where there are some predefined set of classes. For example, a spam or a non-spam. For example, a news article falling in a category say sports, politics, local. So, there are defined categories, and you have a training example, a set of training example, where there is a supervised output. That means, for every example what should be the category, it is mentioned. So, if I quickly write down, a set of predefined categories or you have a training set where not only the attributes of the examples, but also the class labels are available. You have to predict the class label for a new example. So, you have examples of say spam and non-spam email. You have to predict a new email whether it is spam or not a spam. So, there are two aspects. One is there is this class level information along with 10 attributes, which is called supervised learning. Second is you are predicting for an unknown example, why it is predictive mining. Okay. So, these are the two important problems. Similarly, we also saw another task we also saw the clustering task, where no predefined classes. Okay. you just try to find the homogeneous groups in the data. So, it is that is why called exploratory data mining. And training examples, they have attribute values only. No class information is available. Okay. So, nobody tells that for this example this should be the class. So, there is no supervision. So, it is unsupervised learning. It is exploratory and unsupervised. Now, we look at another problem. It is predictive data mining. That means you predict the output, okay. But output is not a class. It is not a class. It is, if it is a class, we can probably represent them by replace them by integers. Say spam is 0, non-spam is 1. Okay, fraud is 0, non-fraud is 1, fraud is -1, non-fraud is 1. We can represent them by a, but here it is not a class. So, output is no longer an integer, output is a real value. Okay. So, regression is predictive mining where output is real. And you still have a training set. So, it is supervised also. Learning also. Okay. So, some examples, maybe you have gone to weather.com and you want to predict the rainfall, let us say in centimeter for the next 1 month, so some real value, say 230 centimeter or something. Or for example, you want to predict the value of a stock in the next day, that is also a real value. Whereas, if you predict if the stock goes up or goes down, that is a 2-class classification problem. Okay. Another example many people study is the number of users who will, or the fraction of users who will click on certain internet advertisement. Okay. So, these are all examples of regression. one of the most common technique of regression is what is called a linear regression. Okay. Now, let me explain what it is. So, what is given to me is at a set of values of x, x1, x2, x3, x4 up to say xn, I have the corresponding output, okay, so y1, y2. So, xi, say for example, say is the temperature today of certain place, and yi can be volume tomorrow, okay, rainfall volume tomorrow. All right. So, there can be other also. Let me take another example. So, is let us say okay. Said how does traffic density, number of vehicles in a road depend on temperature? Okay, if it is very hot, people do not go out, if it is very cold, people do not go out. So, can I predict the traffic density as a function of the temperature of the day? And it is a regression problem. Okay. So, in general, training set consists of y n. Given a new point x n plus 1, what should be the value of y n plus 1? Okay, that you have to predict. All right. So, maybe you extend the curve like this and see what value it takes, like that you do. Okay. So, this particular example, when the x has only a single value x 1 x 2 is called a univariate regression. Okay. We can have multivariate. Okay. Next. Okay, so here it what will be and so on, and for a new point, sorry, one you have to predict this is multivariate. So, basically one point here you have to predict it for 2 given x 1 x 2 you have to predict y. Okay. So, let us see some example of multivariate regression. pressure. Based on humidity and pressure, you predict the temperature place. So, there are two inputs bivariate and one output. Actually, in general there can be multiple outputs also. Okay. So, let us write down what is called a regression model. Regression model is nothing but expressing y as a function of the input x. Okay, as a function, if it is univariate. Okay, so these are the attributes, this is the attribute. For multivariate case, multiple attribute, univariate one attribute. Y is called the output or the dependent variable, whereas dependent variables. And f is called the function of the regression model. Okay. So, the idea is that dependent variables, or idea is okay, that is the idea. So, now basically f is this function, f is this function. So, what is linear regression? When f is a linear function. Okay. So, for linear regression, some constant alpha 1, alpha 2, or not alpha, let me write them as A1, A2, okay. So, f is this linear function, f is this linear function. Are called the regression coefficients, A1, A2, AK, A0, they are called the regression coefficients. Okay. So, just f is of this particular form, A1, A2, A, simple. Okay. So, in the univariate case, defined values if they are given, then A1x straight line, A0 is the shift and A1 is the slope. X2. In bivariate it is a plane. Okay. So, that is linear regression as you can expect. If you are given some regression points, say x1 y1, x2 y2, given some points, such that so basic so you find values of A0 and A1, so that the given data it matches. best fits the given data. Okay. That we will find out. If we have higher dimension, we have more terms. So, all these terms you have to find out. Okay. So, that is the regression design problem. So, that we will do in our next lecture, how to find that. Thank you.